Hello everyone, myself Newton Ashok Chaudhary. I am presenting our Computer Integrated Manufacturing Systems project, Autodesk Fusion 360 for modeling and implementation of DFM and DFA of RC engine. In our project, myself and my two teammates, Ali Ahmed and Atif Khan, we have done this project under the guidance of Dr. Liu and Dr. Kanaria. Why we chose RC engine for our project? Because as we know, in today's advanced world, mechatronics is the king where all types of modifications are going to happen. Whenever we talk about the aeroplane, first thing that comes in our mind is radio controlled engine, which is RC engine. A RC engine is a glow engine which uses glow plug to ignite its fuel and air mixture in the airplane. The most common type in this engine is a nitro plug glow engine. Here we know two main types of RC engine. First, two-stroke RC engine and second, four-stroke RC engine. For this project, we are going to use two-stroke RC engine. The reason behind using two-stroke RC engine is this is the most common type and easy to assemble. And very important thing is cost of the manufacturing is very low compared to four-stroke engine. Here we are using few tools for design purpose, modeling purpose and assembly purpose. In that, first one is solid modeling, which is consistent set which is useful for mathematical and computer modeling of the three-dimensional solids. After that, we are using Autodesk Fusion 360. It will be made in use to design parts and assembly. It complies with industrial and company standards. CAD, which is computer aided design. It is useful to design the parts of the RC engine. CAM, it is computer aided manufacturing, which is useful for manufacturing purposes. After that, key components of RC engine, where we have total 15 parts of assembly of RC engine. In that, first one is crankcase, second sleeve, third cylinder sleeve, fourth cylinder fins. After that, cylinder head. We have used two types of bolts. First one is size of M 3.5 into 0.6 into 9 mm. Second bolt is M3 into 0.5 into 30 mm. After that, crankshaft, connecting rod, piston pin, drive washer, propeller, spinner cap, backplate. These all parts we have used for the RC engine. This is the part models which I have done in Autodesk Fusion 360. These all are 15 parts which we have used for the production assembly of RC engine. Assembly of RC engine. As we have learned Autodesk Fusion 360 in our course, so we have used Autodesk Fusion 360 for the design purpose, modeling purpose and the assembly of RC engine. I have used joints function to joins all parts of the RC engine. Which we have shown in next slide. We are applying DFM, which is designed for manufacturing for cylinder head and connecting rod. This is the assembly of RC engine which I have made in Autodesk Fusion 360. This is the complete assembly of RC engine by using different tools, by using different functions which we have in Autodesk Fusion 360. I'm going to stop here because I'm handing over the next part, which is DFM design for manufacturing, to my project partner, Ali. Thank you.
Hello everyone, we have seen how Fusion 360 was used to design the assembly. Now we'll be applying the concept of DFM on these parts. DFM will be used to optimize the ease of manufacture by keeping in consideration the fits and requirements. We brainstormed the possibilities for implementing DFM. The cylinder head and the connecting rod came out to be the suitable parts to be considered. Design for manufacturing on the cylinder head. The fins and their alignment with valves in the original version of the cylinder head are difficult to manufacture and utilize excess material. The DFM version of the cylinder head has fins less in number and with curved edges, which make the product easy to manufacture. Coming to the connecting rod, the DFM on connecting rod involves as follows. The original version had its rib in the middle, which would require two machining setups. The rib had scope of material reduction, which was not utilized. The DFM version of the connecting rod had its rib on one side, which made it easy to manufacture, and the manufacturing process would be less time consuming. The slot on the rib reduces material usage. So these pictures here represent the changes that we have made. We can see that changes in designs are efficient in easing the manufacturing process since they acquire less material and time. Implementation of DFA. Using DFA will ensure that number of parts are reduced. This gets ease in assembly and less time consumption. Here, the bolts have been considered to undergo DFA since the crankcase, the cylinder fins, and the cylinder head are connected to the bolts. The original version had two types of bolts, which were 3 each in quantity. We make use of single type of bolt in the newer design, which makes the assembly easier and cost effective. The reason behind using one bolt also reduces the number of products on the bill of materials. This slide shows the exploded and the assembled view of the original product. Which seems to be complicated, but when we come to the assembled view and the modified view of the product which we made after DFM and DFA seems to be similar, seems to be simple and less complicated.
Hello everyone, as we have seen the design and assembly using the Autodesk Fusion 360 and the DFM DFA analysis, now we're gonna look at the computer aided manufacturing CAM. Computer aided manufacturing is the tool or program that uses numerical codes to create detailed instructions. These instructions are an input to the CNC machines. The machining process is streamlined and processes like drilling and milling can be automated, resulting in high quality manufacturing. CAM modeling. So computer aided manufacturing will be utilized to manufacture the cylinder head and connecting rod from the RC engine. Fusion 360 will be used to write the numerical code and provide the CNC with G-code inputs. This part has been chosen to be manufactured by computer aided manufacturing because its manufacturing quality determines the efficiency of assembly, which is RC engine. CAM modeling. The cylinder head and connecting rod had been redesigned with DFM. The previous design of both parts would utilize a complex setup for computer aided manufacturing and would also consume more time. The newer version of the cylinder head and connecting rod makes the computer aided manufacturing setup simple and milling process would consume less time. Here we can see the CAM automation using the Autodesk Fusion 360. Results. RC engine is a very popular machine for the airplane. We have chosen this topic because somehow we wanted to make few changes in model and make it cost effective with less manpower and with the help of less machinery. We have combined few changes which we have made in the project as shown in the next table. As seen in the following table, by doing the modifications in the product, we have achieved the following results. We have less use of machinery, low cost of product, and less labor cost. Conclusion. As seeing modifications done in the model and assembly, hence we can conclude that modified product meets the desired expectations without altering the basic functions of the product. The required modifications had been done by design for manufacturing, design for assembly and analysis. We have achieved primary goal of the project, which is improvement in material strength by reducing various types of cost. These are the references that we have used for our project. Thank you everyone.